Hi everybody, in lesson 14 we put everything we learned together in this unit. We put it all together and see what we learned about solving quadratic equations. So quick review, quadratic equations are the x squared equations and there's three methods we learned. The zero product property and factoring. That's the first method. The zero product property and factoring, that's one choice you have to solve the quadratics. We have completing the square, and that goes with inverse operations. And then the final method is what we just learned was the quadratic formula. So factoring sometimes works. Factoring is one of those quick sometimes methods. Completing the square always works, but can get messy. Quadratic formula also always works and takes care of those messy completing the square cases where you're going to say that's too hard, let's use the quad formula. So those are our three methods that we have to solve quadratic equations. We can use the zero product property after we factor. We can complete the square and then use inverse operations, or we could jump right to the quad formula. So for this quadratic equation here, x squared plus 6x, watch what I'm going to do. I'm going to subtract 16 from both sides because regardless of what we're going to use, we're going to want it set equal to 0. So take a second right now and pick one of these three methods to solve this quadratic equation. They all work for this one. Pick one of the methods and go with it. So pause the video and try to solve that. So the fastest is going to be factoring. We're going to ask ourselves, what multiplies to negative 16 and adds to 6? Well, what makes 16? 1 and 16, 2 and 8. I'm thinking 2 and 8 here. So it factors as x minus 2, x plus 8 equals 0. So your solutions are negative 8 and 2. Done. Factoring is definitely the fastest of these three cases, but it does require you to do a little bit of thinking to figure out this add multiply problem we made. If you did the other two methods, you're going to end up getting 2 and negative 8. So these are our cases, and this is what we're going to look at this unit. Here's this lesson. Here's a quadratic equation. How do I solve it? So for each of these here, we're going to use the different methods that we've learned. So x squared minus 4x equals negative 2. Well, let's add that 2 over to get it equal to 0, because when we solve quadratic equations, we set them equal to 0. I could try factoring. What multiplies to 2 and adds... Nah, there's no way that's going to work. Let's complete the square. I like completing the square when the middleman is even. So let's add that here. Middle term is even. That way it gets cut in half nicely. Because remember, when we complete the square, we're going to draw a box and cut the middleman in half. To get the magic number I need to add to make the square. Look, I physically made a square there. I made a square by adding in the magic number of 4. But I can't just add in 4, so I'm going to subtract 4. I can't just add in 4, so I'm going to subtract 4. Now we factor x minus 2 squared minus 2 equals 0. I'm done completing the square, so now it's set up for inverse operations. I'm going to add that over. I'm going to take the square root. And remember, when you take the square root, you need to put a plus or minus in front of it. And the final step is to add that 2 over. So my solutions are 2 plus or minus the square root of 2. Those are my two irrational numbered solutions. So they're irrational, so factoring's not possible. You could have used the quadratic formula, but this was a good candidate for complete the square because of that even b value. This next one over here, definitely not completing the square because you also want to do plain old x squared. You want plain old x squared and an even middleman. This has neither of that, so we're not even going to try completing the square for this one. Let's try factoring. Factoring's quick if we try it. So let's try it. Remember, factoring, you put the first term and the constant. You use the box differently when you complete the square. And we ask ourselves, what multiplies to negative 24, their product, that adds to the middleman? Well, I'm thinking it's -8 and +3. Yeah. 2x goes there, which makes that a plain old x minus 4. And that's a +3. So factoring was actually a quick method here. You could have used the quadratic formula and you would have got the same solutions that I'm getting right now. But factoring, if you can do that quick little add multiply step, it becomes a little bit more straightforward. Let me just set that term equal to 0. There we go. X equals -3/2. So we can use factoring in the zero product property. So once I had it factored, I used the ZPP and set each factor equal to 0. All right, so we completed the square. We factored. Let's see what's coming up here. Well, wait a minute. Look at this. There's x. Someone already completed the square for us. So let's just use inverse operations. Let's use inverse operations here to solve this quadratic equation. I know you want to distribute, but remember that squared's there, so you have to divide. That squared is in the way, so you have to divide. So it's just like completing the square, but someone already did it for us. Someone already completed the square for us, so I'm already a step ahead and just have to apply the inverse operations. I'm undoing everything that happened to x by applying the opposite. Let's look at radical 90 and split that up. Radical 9 and radical 10 is what I'm thinking, so 3 radical 10. So x equals -2 plus or minus 3 radical 10 is my answer in simplest radical form. I believe it said that here. Solve each of these quadratic equations, keep track of the method you're using. It doesn't, so actually you didn't have to do that. But this was just using inverse operations because you saw x once. Isn't it great when we get to put a 14 lesson unit together? Fantastic. I completed the square, I factored, I used inverse operations, so I hope you're warming up your singing voice because this is probably going to be the quadratic formula. Get it equal to 0. You can only use the quadratic formula once that trinomial is set equal to 0. Give me an A, 2. Give me a B, 6. Give me a C, 1. Here we go. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. 2 times 2 is 4. And then we type in that number under the square root. No square root in your calculator, just the number under it. 6 squared minus 4 times 2 times 1 gives me 28. So I end up getting -6 plus or minus the square root of 28 over 4. So we're basically done. We just have to tackle radical 28. How do I split up 28? What perfect square divides in? 4 is always a good try. 4 is always a good try. -6/4 plus or minus 2 radical 7/4. So I split up that fraction. I divided and divided so I could simplify. Plus or minus 1/2 radical 7. Those are my irrational solutions. So why didn't I complete the square here? I didn't complete the square here because there was a leading coefficient. I only like completing the square when you have plain old x squared. I could try factoring, but it's not going to work because the solutions are irrational. The roots are irrational. So at this point, we're going to solve 5 more. We're just going to keep on practicing because this is the end of the unit where we get to put everything together. So solve each of the following quadratic equations, get practice at using the different methods by picking the most efficient one. That's what this is all about, being efficient, picking the best method. Like, I'm not going to use the quadratic formula here. I'm not going to use the quadratic formula. I'm going to say, wait a second. This is the difference of perfect squares. This is DOPS. X minus 9, x plus 9. I'm going to factor there. I'm already done with this quadratic equation because I realized it's set equal to 0 and I can factor it. Using the zero product property, I get 9 and -9. So x equals plus or minus 9 is my answer. You could have also used inverse operations. That was another choice for that one. Speaking of inverse operations, look at this one here. Someone already completed the square for us. Someone already got it into that structure of something squared with a kind of a leftover. So let's get x by itself. Let's add 40. I guess I should have said pause the video and try these problems on your own first, but I've already started, so we'll finish this one up and then I'll kind of suggest that. X equals -4 plus or minus the square root of 40. Well, we got some tearing apart to do here. I'll give you a second because your pencils clearly haven't caught up to mine yet. I apologize. I apologize greatly. Radical 4, radical 10. So 2 radical 10. So my final answer here is -4 plus or minus 2 square roots of 10. So far we factored with some difference of perfect squares, and now we used inverse operations because someone already completed the square for us. I'm going to say skip this next one. I'm going to say this is a challenge problem, but the first thing you have to do there is make a box, then get it equal to 0, and then solve it. So if you want to challenge yourself, you can try that one. Otherwise, you can say goodbye, goodbye. All right, so at this point, I've got 3 problems left. Pause the video and try them on your own first. Try them, see what you can do, see if you can use the quadratic formula. When all else fails, use the quadratic formula. Otherwise, try factoring, try completing the square, try something. That's the important thing, is that you're actually trying something. So I'm going to assume you did some work and unpaused me, and here we go. Let's get this equal to 0. X squared minus 8x plus 1 equals 0. I'm definitely not going to factor this because what multiplies to 1 and adds to -8? So this is a perfect candidate for complete the square. Why is this good for complete the square? X squared, and it's got an even b value. So let's draw our square. I like when that number is even because I'm cutting it in half. We cut our middle man in half, which gives me what makes the square, what completes the square here. 16 is the magic number. 16, come on down, the price is right. Should have been a game show host. So I add that 16 and I subtract it, so now that I could factor this. Well, how does this factor? Well, look at your box. We made that box so that it factors. And now we just need to finish this up. Now we just need to finish this up with some Schminverse operations. We'll do some rhyming clues there. Rhymes with Schminverse operations. Take the square root. X minus 4 equals plus or minus the square root of 15. So my final answers are x equals, add that 4 over, positive 4, plus or minus the square root of 15. Now, the only way I could think of tearing apart 15 is 5 and 3, so I'm not going to do that. I'm not going to do that because they're not perfect squares. So this was a perfect example of completing the square. You could have done the quad formula, but complete the square worked better. I could try factoring, but you know what? Let's just jump right to the quadratic formula. Completing the square is not even a choice for this one, unless you're insane. So let's do a little quadratic formula. A equals 2, B equals 3, and C equals -1. And now we get to plug them in. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2 times A, which is 2. 2 times 2 is 4. Type that on into my TI-83, which is 84, sorry, which is sitting right next to me. 3 squared minus 4 times 2 times -1 is 17. And I like that it's 17 because that means I don't have to do any more work after this step here. I mean, I could split it apart. X equals -3/4 plus or minus radical 17/4. But I can't split up 17. The only numbers that make 17 are 17 and 1. 4 doesn't divide into it, and 9 doesn't divide into it. So I'm going to leave it alone. This was an awesome quadratic formula one. Quick, easy, and you just have to plug the numbers in. I don't know. Well, there's a GCF. Regardless of what method I'm going to do, I'm going to kind of divide everybody by 3. I can divide everybody by 3, and it makes my life a little bit easier. I actually think you can factor this, but you know what? I'm going to be lazy because it's been a long time since we factored. Let's use the quad formula. And it's going to give me the same answer even if you did factor it. X equals negative b plus or minus the square root of negative 5 squared minus 4 times 3 times negative 8 all over 2 times 3, which is 6. I find this a little bit easier than factoring sometimes, just because you have to plug the numbers in and hope for the best. Negative 5 squared minus 4 times 3 times negative 8 is... Oh, I could have factored it. How do I know I could have factored it? I got a perfect square. This guy right there, that was supposed to be a highlighter. This guy right there is a perfect square. What is it? It's actually 11. 5 plus or minus 11 divided by 6. So let's see what our answers are. 5 plus 11 is 16 over 6. 16 over 6 simplifies down to 8/3. Or it could be 5 minus 11, which is negative 6 over 6, which is negative 1. So I could have factored. I could have made a box and factored, but when in doubt, the quadratic formula always works, which is the beautiful thing about it. So that's it for solving quadratic equations, guys. Next week, the next set of lessons are going to be practice problems. We have a lot of quadratics to practice. We got to get good at completing the square. We got to get good at quad formula. So the week after this probably isn't going to be new content. It's going to be light. But this is the end of Unit 8. It's been a big unit. It's probably the hardest unit we do all year in Algebra 1. And you guys got through it, and you did it virtually through the computer. So pat yourself on the back. Give yourself a clap on 3 because you guys rocked it. Do your homework, practice the problem set, and I'll see you guys soon in a video.